Hey all, Dan here again today, talking about measurement gear, kind of the next few steps we're going to talk about. A little more of an in-depth into the top box here, the Audio Precision APX 515. I'll show you a little bit of the software kind of things like that over the next few videos as well to kind of tell you what you got. So again, reminder, the APX 515, that's the main box. We've got a filter that we use for like switching amplifiers, switching power supplies. Got a transducer interface, got a little microphone interface over here for my boy, Chucky. Anyway, so yeah, that's Chucky. That's our hats. So today we're going to talk a little bit about the software. So there you can kind of see the software. This is just Audio Precision software. It's pretty straightforward. This is actually some measurements I took in my anechoic chamber, which is this big, huge room behind me. To let you know, of a sound bar I'm working on for a company. What we can see here is I'm looking at frequency response, right? We got this curve over here. We see a frequency response as an elevation speaker. It's a Dolby Atmos enabled sound bar, so it's got elevation speakers. It's got the front one. And so essentially what this does is it's going to do a sweep. In this case, I've got it set to go from 50 hertz to 20 kilohertz. This is the output level that's driving it. This is pre-sweep. In other words, do we wait a little bit? How long did the sweep last? In this case, it's 350 milliseconds, so 0.35 seconds. Go whoop, the whole thing in one sweep. Extend to collect any additional reflections and stuff like that as needed. Everything else. So that's kind of some of the basics there. And over here, you can see we can actually measure the actual RMS level. Wow, that looks messy. But then when we go ahead and say, well, let's look at it with a 1/6 octave smoothing on it. Hey, that looks a lot better, kind of a thing. We can look at all kinds of stuff over here, though, that it's got capable of. So, for instance, really what I'm interested here is the RMS level, which you see here, which is in dB SPL. It's calibrated. So this is at basically a nominal 100 dB SPL level. And what's the THD of the thing? Well, here we see, here's the main channel. The center channel of it. It's actually pretty good. It's below about 2-3% over almost all the bandwidth. The elevation speaker doesn't do quite as good, but it's a lot smaller, and it's not, doesn't do quite as high of output, things like that. But so this is THD again. This is frequency. So that's some of the things you could do. But you can do all kinds of stuff. You can look at group delay, and you can look at phase. You can look at deviation over frequency. You can look at all kinds of stuff. What the actual waveform was. This is what was actually acquired during the clip. If you look at it in the sweep, things like that. So this is a little bit of it. You can capture all kinds of crazy things with the Audio Precision to very high levels. In this case, I was using microphones on the external. We'll be covering that a little later. And using the AP to do all the processing, capturing it, distilling it down, and doing a nice little report. So anyway, so that's a little more about that box. We're going to move on to the filter next on the next video. And then we're also going to talk about the transducer interface. And then we'll be talking lastly about some of the microphones I got around here. I got various high-end microphones. I got, obviously Chucky, our hats. I've got some, 7-Eleven couplers like you'd expect from anybody who does IEMs, things like that, and some other various microphones that we got testing and microphone calibrator, things like that. I'll show you how that all works together. So there you go. That's a little more about the detail. It's a little more complex software to set up and to get running, but once it's going, it's freaking awesome. You can measure just about anything you want to measure, which is the important part. So there you go, all. Again, Dan Wiggins, Periodic Audio. I'll talk to you later.